Okay, so procedural content is very, very cool, but it's also kind of intimidating. It's very difficult to approach, so I'd kind of like to present a nice and simple way to go about it that makes it easier to compartmentalize and hopefully easier to work on. Uh, it's kind of always at least a little bit hard though, so it's not like a magic solution. To start off though, we're going to warm up with three very easy questions about procedural content in general. So first of all, why is it cool? Second of all, why is it not cool? Third of all, when should you use it? And it turns out these are actually very, very easy to answer. Uh, if you're here, you already have your own reasons for liking procedural content. It's definitely harder than traditional content. If you want to make the same thing generated versus traditionally, it's going to look better if a human made it because humans have insight. It's going to come out nicer. But you can end up with a lot more content if you do it procedurally, so sometimes that can be worth it. So basically, you just have to be very careful, and like all things in game design and like any other form of design, you have to figure out if it's appropriate for your project or not. Anyway, those are pretty simple, so we're going to move on. This is the really hard question. Where the shit do we begin? A lot of people get to this point, and it's like, okay, yeah, I want to make randomly generated enemy types, and then they sit down to code it, and they go, and they have nowhere to go. So we're going to start off by talking about a few basic types of randomization. These are kind of like the fundamental building blocks. The first one is like the basic dice roll. Any property, just set it to a number between here and here. There's a few examples of types of that. And even though this is like the simplest thing, like the most fundamental randomization method, you can already make really fancy stuff with it, like a noise function, like Perlin noise, or like the static on a TV when there's no cable. People use that to make stuff like height maps for like randomly generated terrain. So even just the most basic method in a grid, you can already get some kind of cool results. If we take that one step further, we can pick a random index out of a list of handmade things. So like when you pick up an item box in Mario Kart, you're not sure what you're going to get, but you know it's going to be a Mario Kart item. And they can kind of use that to balance the game too. So if you're in first place, you get worse items, and if you're in last place, you get better items. And that can kind of affect the way it goes. And basically any kind of randomized stuff is just going to be a bunch of combinations of these like stacked up on top of each other. And there's a few ways to go about that. So a really popular one these days is something called chunking. There's probably nicer names for this too, but this is the way that Spelunky and Binding of Isaac work, where there's a lot of like pieces of handmade content, and then the game like organizes them at random. So when you play Spelunky, each map is a big square, and it's made up of 16 smaller squares, and each one of those is like handmade terrain with little spots to put in like a chest or like an enemy or something like that. But ultimately, the terrain itself is handmade, so they can know what type of quality it's going to have because they made it themselves, and they can just make sure they all line up in ways that make sense. And this is very cool, and you can get a lot of results with a very reasonable amount of effort, but it's kind of unfortunate because eventually the player starts to recognize these patterns, and people are really, really good at recognizing patterns. It's like kind of our thing. So when you start to realize that, it makes it seem less variant than it really is, and it kind of distracts you from the game itself. So what we're going to be talking about is another method called fitness-based randomization, which tries to avoid that problem and kind of make the process a bit closer to a regular person's design process, and less like a DJ. So 7 steps for design-centric, fitness-based procedural content. Now this is an unnecessary mouthful, so I'm going to run away from this slide as fast as I can, and we're going to go straight to step 1. So for starters, you want to make sure that you completely ignore that you're doing it procedurally and just draw some examples. And this is the point where you realize that if you can't make it by hand, you really can't make it procedurally either. So you can't use it as a crutch. It's like, well, I don't really want to make these myself because I don't really know quite how to do it, so I'll just get the computer to do it, but it's going to come out worse. So if you can't do it normally, you definitely can't do it like that. So we're going to start by sketching. Pen and paper or your totally legitimate copy of Photoshop, whatever, just like draw up some simple examples of whatever you want to make. So these don't need to be great, they don't need to be fancy, they don't need to be huge, you don't need to spend a lot of time on them, you just need to make a few. And once you've made a few of them, you start to realize that you have like a certain process you go through every time, like certain things you never do, certain things you always do. And once you get a feel for that, you can try to summarize it. And this is like the kind of design summary that would really offend an art school student. Like if we're trying to pick colors for a color harmony, we're just going to pick anything, and then we're going to travel some distance in both directions around the color wheel, and those are going to be our other 2 colors. So if you do that with different angles, you get different types of color harmonies. Like if it's a small one, you get an adjacent color scheme. If it's a big number, you get like a complementary color scheme. If it's in the middle, you get like triadic and stuff like that. And this kind of simulates a whole bunch of things. And I don't know, it just kind of comes out of the idea that like this is pretty much what you do when you're trying to pick 3 colors that look nice. It's like, well, what type of match do we want, and what are we starting with? And then that's basically it. So when you do that, if you've thought about this carefully, it should be very, very, very easy to convert that into code. And if this is hard, it's probably because you should make some more examples and think about it a little bit more. Because I find that generally speaking, this part, like the code here is like 100, 200 lines maybe. They're always very, very simple rules. Uh, and the better you plan it out, the easier it becomes. So oftentimes you can spend like a week or two planning out how you're going to do it, and then you sit down and it takes like an hour. And that's really nice. Now at this point, we have a working prototype, so we need to study the hell out of it, and then we need to make some adjustments. Like always, this is still game dev, so it's still all iteration. And maybe we're already done. The game that I'm working on uses that color scheme generator, and it actually doesn't need to go any farther than this because it already is consistent enough. But if it's not, maybe we can make some adjustments. Maybe our ranges could be bigger or smaller, and maybe we can weight them. So like when you roll 2 dice, you're more likely to get a 7 than you are to get a 1, or sorry, a 2. You can also do the opposite of that by applying smooth step to a random, and that makes it more likely to get a low number or more likely to get a high number and less likely to get a middle number. And then this, taking a random number and raising it to a power, you can either weight it downwards by raising it to a power of like 2 or 3, or you can weight it upwards by raising it to a power of like 0.5. And you can use basically any normal easing function that you would use for animation and stuff like that. It all applies to random numbers too, so you can kind of change how the weights work and how the ranges, what's more likely to happen. And often this is enough, but if it's not, we need something called a fitness function, which is basically anything that measures the quality of a result. And that's kind of an amorphous concept, so let's see what we mean. We're going to study our results some more, and we're going to figure out what stuff we like and what stuff we don't like. So basically just like look at a bunch of your generated examples, and if you see one you think is very good, write down why it's good. If you see something that's very bad, write down why it's bad. And when you start to do this a few times, you start to realize like the most important metrics. There are certain things that are like especially important to make it either good or bad. There's some kind of simple examples here of like different types of things that would measure how nice these different types of content are. So once we've got that, we can kind of repeat step 3 with this and convert these flavors into like measurable metrics. So these are just like 3 examples of the same things we just mentioned, but in terms of like numeric things instead of like vague concepts. So if we want to make sure that enemies aren't too close together, because that would be annoying, we could just measure the average distance between each pair, and then figure out which one is like the middle ground. Because if the average distance is very small, then they're all clumped together, and if it's huge, then they're all really far apart, and it's kind of boring because it's too spread out. So in that case, we kind of want the one that's in the middle, but it really just depends on the fitness function. And once we have that, we get to the kind of only magic trick in this process, which is at load time, instead of making one piece of content, we're going to make, say, 5 or 10, and then measure all of them with your fitness function and only use the best one. And that way we have this process where it's like kind of very similar to how a person actually works. You like make a bunch of examples and see which one you like the most. And as long as your fitness function and your generator function aren't using the same things, they kind of interact in very, very cool ways. And it's very important to note here that the fitness function might be a high number for good, or it might be a low number for good, or it might be a middle number that's good. So you can use the maximum or the minimum or a median or like a biased median, like 60%, something like that. And really that's kind of it. So let's kind of see an example of what types of content we can generate with this. So a bit of a weird one is to make wallpaper patterns, like these guys here. The game that I'm making takes place in an office, so it's got to have a bunch of like tacky wallpapers. So we generate those instead of just having a set, because, why not? So we're going to begin by rendering a bunch of random samples of random fractals, because that's just like going to give us some weird blobby shapes. And a lot of wallpapers are basically just blobby shapes that repeat a bunch. So we're going to do that, and then we're going to measure the fitness according to how much white space they have. And it turns out that the ones that are the most appropriate are the ones that have 30%-ish white space. So like these guys here. And when we have the 2 that we like the most, we're going to replace all the white space with random noise, so it's just like total garbage, and then we're going to ping pong tile that across a big square. When we do that, we get these 2 patterns like this, and then we can just kind of fade vertically between them, and we end up with that. And then we can just kind of colorize it, and we're all done. And we can just make a whole bunch of stuff like that. So then these are generated pixel by pixel, so they have a huge amount of variation, but we can be pretty confident with how good they'll look because we sort of know the whole process. And they're measured according to fitnesses that we think are appropriate. And I don't know, the neat thing about this is that you really don't have to do it for something wallpapery or something visual. I'm using this method to generate room layouts. I'm using it to place enemy positions to make sure they're fair and whatnot. Uh, it places like sequence objectives where you have to run across a certain path. It figures out how appropriate that path is going to be fun. And you can really do pretty much anything you can make by hand, which is very exciting. So if you want to see some more examples of this, I have my game Not the Robots out on the Indie Showcase. I'm on the left side. And I don't know, it's basically just a whole bunch of examples of this type of method, all smashed up into one. And that's about all. If anybody has any questions, I'm here. Yes. Yeah, I can hear you. Yeah, perfect. Okay. Right. Yep. Okay, it's actually kind of strange there because the placement of all the office furniture has no interest in looking like a functional office. It's a bunch of stuff that you would find in an office, but it's supposed to look kind of ransacked and jumbled up, and that's just because I don't want to spend as much time as I would need to make it look like functional and working. Like I think that's just kind of outside of the scope of the project, and it seems like it would add too much to the load time to be worth it. But after it places the walls, like the room layouts, very carefully with using a fitness function and whatnot, it really just places a bunch of office stuff down and then puts a bunch of stuff on top of it. So cases like that, there's no fitness function at all. And it's just good enough to just place it all random. For the walls that make like the actual, yeah, those definitely yes. Um, Not that long, maybe like a week. So it's like a whole bunch of things. That's like one little part of it, and then there's just a bunch of other stuff stacked onto it too. They all kind of interact. Oh, I just fancy people would call that focus testing. I just get people to play it and just kind of stand behind them and see what they do, and kind of see what they say about it and see how they react to it. And I don't know, you can kind of intuit what's right or wrong from that eventually.
Anybody has any more questions? Okay, that's it then. So you can meet him at the game stall, and if you have any further questions you want to ask in detail about procedural generation, then you could probably speak to him. Yep. All right. Thanks so
Thanks.
much, Eli.
Mm-hmm.